Let's look at two special triangles and where they come from. Let's start with a 45, 45, 90 triangle. This means my three angles are 45 degrees, 45 degrees, and 90 degrees. So this is an isosceles right triangle. That tells me that two of the sides are going to be equal. And for simplicity, we'll call both of those sides 1. Since these are opposite the congruent angles, the sides will be congruent. The Pythagorean theorem tells me that 1 squared plus 1 squared is equal to my hypotenuse squared. This is 1 plus 1 is equal to c squared, or 2 is equal to c squared. Therefore, c is equal to the square root of 2, and I have that a 45, 45, 90 degree triangle has the side lengths of 1, 1, square root of 2. Next, let's look at a 30, 60, 90 degree triangle. So my three angles are 30 degrees at the top, 60 degrees at the bottom right, and then 90 degrees at the bottom left. In order to figure out this ratio of the side lengths here, I'm actually going to take a second copy of this triangle on the other side. So I'm going to create a mirror image. Once I do that, this angle down here will be 60 degrees, and the big top angle will be 30 plus 30, or 60 degrees. So this is now an equilateral triangle. If I make one of the shorter sides down at the bottom 1, the entire length of the bottom of this equilateral triangle is 2. So that tells me that the hypotenuse is also a 2. So I have a 1 for the shorter leg and a 2 for the hypotenuse. We then use the Pythagorean theorem to say that 1 squared plus b squared is equal to 2 squared, or 1 plus b squared is equal to 4. I can subtract 1 from both sides to get that b squared is equal to 3, or b is equal to the square root of 3. So the side length ratios for a 30, 60, 90 degree triangle are 1, 2, square root of 3.